All right, today's lesson is on graphing functions. So remember that you should be able to pass the vertical line test on these. So if you mess up on your math, be careful. And probably the vertical line test would not work if you mess up your points. All right, so how do you do this? So you're going to use the equations on the left to fill in the y values in your table. And all you're doing is plugging your x values in to figure out the y's that go with it. So you're kind of using this guy and you're evaluating 4 times. All right, so if we were doing where x is equal to -1, then y equals 2 times -1 minus 3, and that gives you what? -5. All right, so this would be -5. If x were 0, then y would be 2 times 0 minus 3, which is -3, and so on. So you keep doing that, and you can use your calculator, whatever you have, Desmos, your phone calculator, whatever you want to use to figure this out. 2 times 2 minus 3, so that's 4 minus 3, which is 1. And then one more. And I'm just squeezing them all in here. Y equals 2 times 4 minus 3, so that's 2 times 4 is 8, minus 3 is 5. So 4, 5. All right, and then I'm going to graph these points, and if I've done it right, they should line up nice and neat and pretty. If I make a math mistake, then they'll be not lined up. All right, so -1, -5 is here. 1, -3 is here. 2, 1 is here. And 4, 5 is here. And if I take some form of straight edge, let's see if I have anything. I'll just use this box. And I'll get closer to this. And you can use any straight edge. And there's my graphing of my function. Okay, so again, when you're given an equation, these are just 4 points to help you draw your line. There are unlimited points on the line of this, the graph of this line. So here's just 4 examples, and I've written 4 examples of the ones I want you to look up, but you could pick any 4 you wanted to. It's totally up to you, but here what I'm doing is I'm giving you items in the domain in your x's, your inputs, and then you're putting in your y values. So I'm not going to do any of these because it's kind of you get the idea with the example, but I am going to go on the other side just for the sake of time. You saw how I did it. That's how you do every one of these other problems on this page. And I'm going to flip to the back side of your paper, which says given the domain, find the range values. You're really doing the same thing. It's just presented to you as a domain is in a set instead of in the left side of your table. So again, if I were doing these problems, I don't have to do all of these, just kind of get the idea. If I were going to do, I don't know, I'll pick 12. If I was going to do 12, all I have to do is plug in each one of these numbers in for x. So y equals -2/3 times -12, and this is again when x is -12, plus 9. So y equals -2 times -12 is 24 divided by 3. And again, that's how you always do mathematics that way. The top number is the multiplier and the bottom number is what you divide by. So -2 times -12 is 24 divided by 3 is 8 plus 9. So that's 17. So I'm saying find the range values. So right now, range equals, you're going to put a 17 in there for the first one. Then you do the same thing for x is -6. Y equals -2/3 times -6 plus 9. So that's going to equal to -2 times -6, which is 12 divided by 3, which is 4 plus 9. That's 13. Goes to the next one. The last one I got to do is x is equal to 3. So y equals negative 2/3 times 3 plus 9. Okay, so y equals negative 2 times 3 is 6, divided by 3 is negative 2 again, plus 9, so that's 7. So y is equal to 7 there. So 7, and I'm done. Okay, so when I give you members of the domain, all you're finding is the members of the range using your rule. And again, when we start getting to function notation, which is our next chapter, they change one little thing, but the process is still the same. All right, that's it for me.